up to now, what we've been doing is using the inverse operation of subtraction to be able to transpose terms. I told you earlier that our goal in algebra is to solve for x. We want to figure out what x is, and we take a series of steps to be able to figure out what x is. One of the steps is that before we can figure out what x is, we've got to move all the variables to one side of the equation. In other words, all the numbers that have x's next to them, we've got to move to one side of the equation using subtraction, addition, multiplication, or division. So far, we've only been using subtraction, but from this point forward, we're going to start using division and multiplication to be able to get x by itself so that we can figure out what x is. Looking at problem number 1, I want to get this 7 here over to this side of the equal sign. So what I'm going to do is we're going to subtract 7x here. And that's going to cancel because 7x minus 7x is 0. But what I do to one side, I have to do to the other side to keep the equation equal. So I'm going to subtract 7x from this side. 24x minus 7x is 17x equals 34. Okay, now what do? I want to solve for x. So I want to get rid of this 17 here. Well, whenever you have a number next to x and there's no addition sign or subtraction sign separating the number from x, that means that it's 17 times x. So since when it was an addition, I used the inverse operation of addition, which was subtraction. Well, here I'm going to use the inverse operation of multiplication, which is division, right? The opposite of multiplication is division, just like the opposite of addition is subtraction, and vice versa. The opposite of subtraction is addition. So here I'm going to use the opposite operation, the inverse operation of multiplication, which is division, to solve this equation. Well, if you know how to divide, you know that 17 divided by 17 is 1, right? And 1 times x is x, because anything times 1 equals whatever you're multiplying it by. So again, whatever I do to one side, I have to do to the other. So I'm going to divide this side by 17. 34 divided by 17 equals 2. Now, let's see if we did this correctly. Let's make sure that our equation is right by plugging what x equals back into the equation. So we've got 24 times 2 equals 34 plus 7 times 2. 24 times 2 is 48 equals 34 plus 14. What's 34 plus 14? Well, guess what? It's 48. And 48 equals 48. So that means that our answer is correct. X does equal 2. Let's do the next equation. I want to get all the x's on one side and all the numbers on the other. So I'm going to get rid of this negative 2x by using the opposite operation of subtraction, which is addition. So I'm going to add 2x. That's going to cancel out because minus 2x plus 2x equals 0. And I'm going to add 2x to this side. That gives us 7x equals 28. Now again, this 7x really means 7 times x. And what's the opposite operation of multiplication? What's the inverse operation? It's division. So I'm going to divide this side by 7. That's going to give me 1. And 1 times x is x. So I'm just going to write x down here. And I'm going to divide this side by 7. 28 divided by 7 is 4. So x equals 4. If you'd like, you can check it. Let's check it just for the fun of it. 5 times 4 equals 28 minus 2 times 4. 5 times 4 is 20. Oops. 5 times 4 is 20 equals, and 2 times 4 is 8. So 28 minus 8 is 20. So this is correct. X does equal 4. I might as well do the last problem with you guys. This one looks a little complicated. It isn't. It's a little bit different because we're going to have to move the 14 over here and the x over here. Or we're going to have to get rid of the 14 on this side and get rid of the x on this side. And well, with the 14, I'm going to use the opposite operation of subtraction, which is addition. And with the x, I'm going to use the opposite operation of addition because there's no sign here, so it means that it's addition. I'm going to use subtraction. So this equals 0. This equals 0, but what I do to one side, I have to do the other. So since I added 14 on this side, I'm going to have to since I added 14 to this side, I'm going to have to add 14 to this side. Since I subtracted an x here, I'm going to have to subtract an x here. And what I get is 4x minus x is 3x, and minus 2 plus 14 is 12. Why? Well, because the positive, pretend that we're talking about money here. The positive in front of the 14, it means that you have $14. The negative in front of the 2 means that you owe $2. Well, once you pay what you owe, how much are you going to have left? You're going to have $12 left. Okay? So it stays positive because that's money you have left. Now, if the 14 would have been negative and the 2 positive, let's do that really quick. If the 14 would have been negative and the 2 positive, that would have been money you owed. You would have owed $14 and you would have had $2. So if you would have paid with the $2, you would have still owed $12, and your 12 here would have been negative. But since this was positive and this is negative, it's a positive 12. You have $12 left. Now what do we do? Well, again, we know that this means multiplication because there's no sign in between the 3 and the x. They're together. They're looked at as one term. That means 3 times x. So what's the opposite operation of 3 times x? It's division. 3 divided by 3 is 1. 1 times x is x. Divide this side by 3 as well, which you get 12 divided 3 is 4. That's your answer. If you want to plug it back in and check it, you can. 4 times 4 minus 14 equals 4 minus 2. Well, 4 times 4 is 16 minus 14, and 4 minus 2 is 2, and 16 minus 14 equals 2. 2 equals 2. That means that our answer here is correct.